Solving absolute value equations. Before we can solve absolute value equations, we really need to look at what the absolute value means. And it means the distance from a central value. Now, most of the time we want to think of that central value as 0. And so really understanding what distance is and the absolute value is, it's that the distance is always positive, and the absolute value of any number is going to be the positive version of it because we're talking about the distance away from a central value. So specifically, when we look at these examples, we have the absolute value of 5. Well, that's 5 away from 0, so that's just 5. Just like the absolute value of negative 10 is just 10, and the absolute value of 0 is just 0. It's the positive version, but really it's not the positive version, it's the non-negative version, because 0 doesn't have a positive or negative version. So using that definition and recognizing that when we're using the absolute value, we're only looking at what's inside. It's not going to be used to change anything that's on the outside of the absolute value. We can actually evaluate an expression for an absolute value. And so we have 23 minus the absolute value of 3 minus 4x, and they tell us x is equal to 2. So the first thing we're going to do is, with parentheses, plug in. We're going to evaluate by plugging in the number where the variable is and evaluating what it says. So since we have an absolute value, it is not like parentheses. So we're not going to distribute across the absolute value. This negative is not going to go in. It's not going to stay there. We're not going to do that. It's not going to move into the absolute value. It's going to stay right where it is. And so what we're going to do is simplify everything inside the absolute value. Then when we get it down to its simplest form, we're going to take the non-negative version, or the positive version if it's a negative number. And then we're going to take that out and then do everything else in the problem afterwards. So we're going to have 23 minus, well, I have 3 minus 4 times 2, which is 8. So I have 3 minus 5 in the absolute value. And so what I get from that is I have 23 minus the negative 2, the absolute value of negative 2, and here is where this comes into play. The absolute value of negative 2 is just 2. So that comes out, and I put in parentheses now. So now that I've actually changed what's inside the absolute value to its simplest form, when I take it out, I'm going to put in parentheses to let me see what's actually happening. And so I get 23 minus 2, and 23 minus 2 is going to be 11. And so when we evaluate our absolute value, the first thing we do is we plug into that absolute value. We simplify everything inside the absolute value. We remove the absolute value symbol by making what's in the simplified version of what's in the absolute value symbol. We make it its non-negative version or its positive version. And then we evaluate the rest of the expression. When looking at our equations, we really want to look at how far away these things are from our central value. So we're going to start with this first one. I'm going to call it letter A. And so for letter A, I'm going to have two things that have a distance of 8 away from 0. Well, two things that have a distance away from 8, well, the only two things I can think of is, well, if x is equal to 8, that would give me one distance. And if x was also equal to negative 8. Both of those would have a specific distance away from 0. Okay? And so really, when I do an absolute value equation, I get not one, but two answers. Okay? The two answers are the positive version of the distance and the negative version of the distance. And really, that's not the best way to say it, but what are we looking at? We're really looking at what's going to the right of that central value and what's going to the left of that central value. So our next step is to take it one step further, where the thing that's inside the absolute value is not as simple as just a variable. It's a variable with something else. Well, now I can evaluate this. I can solve this by saying, well, there's one version of this that I know. The distance away from what I'm talking about, okay? The distance away from what I'm talking about, well, we're going to look at it and it's going to be 8. All right? So that distance is 8. And so when I solve this, I'm going to add 1 to both sides. and I get x equals 9. Well, what does that really mean? Well, the number we're looking at is 9. And what is 8 away from 9? Or it's 8 less than 9? Well, that number is actually 1. And that number that we get is the initial number, the central value, is the value that we're actually going to subtract away from the variable, because the absolute value is the distance. So our central value in this case is actually 1. And so if we really think about it, if we go 8 to the right of 1, we get positive 9. If we go 8 to the left of 1, we're actually going to end up at negative 7. But we need an algebraic way of showing that, right? If we're at number 1 and we go 8 to the right, we're going to end up at 9. But if we're at number 1 and we go 8 to the left, which is the same as subtracting 8, we're going to end up at negative 7. So we've solved for this one, recognizing that we have one version, but we need to solve for the other one. And so when we do the absolute value equation, there's a central value, and then what we do is we do it twice. This would be the first time we do it, where we get x minus 1 equals 8. That's to the right of our central value of 1. Then we're going to do it a second time. And the way that we do it a second time is we keep the same things in the absolute value. We don't change anything. We don't evaluate anything because we're not sure what it is. It has a variable in there, so it could change. So what we do is we change what's on the outside of the absolute value. And what's on the outside of the absolute value is a positive 8, so we want to go to the left direction. And so since going to the right was positive 8, going to the left is going to be minus 8. The minus is just telling you you're going in the opposite direction. And so when I solve this by going in the opposite direction, I still get a distance of 8, just in the opposite direction, and now I end up at the other number I know I was supposed to end up at, which was x equals negative 7. And so I have two possible answers for this. If I was to do the same thing on the other problem, which is x plus 1 equals 8, well, I can't say that we're at positive 1 anymore, because there's even though there's a plus sign in there. But we want to really, again, think of what the absolute value is telling us. So I'm going to do the original version, which is exactly what it looks like. Whatever's in the absolute value going to the right, which is the positive version of what we're talking about. And I can solve that, which gives me 7. And I'm also going to do it to the left. Remembering that to the left just means I change whatever the distance I'm talking about. I'm just going to put a negative, which means I'm going in the opposite direction. So I keep exactly what I see in the absolute value, and then I change everything else to its opposite sign. So to the right was positive 8, so to the left is going to be negative 8. I'm not saying the distance is negative 8. I'm saying the distance is 8, but I'm going in the opposite direction. And so when I subtract 1 from both sides, I get x is equal to negative 9. And that makes sense because if I'm at negative 1 and I go 8 to the right, I end up at positive 7. That's 8 in the positive direction. But if I start out at negative 1, I go 8 to the left, and I end up at negative 9, which is in the negative direction. And so all I'm doing when I solve the absolute value is I'm solving two cases. One for going to the right, which is exactly like the numbers that we see outside the absolute value is. That's what it tells us. And one going to the left, which means I just change the sign of the numbers that are not in the absolute value. Okay, that's the important part. Not in the absolute value. And so this one, we want to do the same kind of things. But we need to recognize what the definition of the absolute value is again. And if we go all the way back to the beginning, okay, distance is always positive, and thus the absolute value of any number is a positive version. So that's what we started out with. That's the notes that you just took. Well, in this case, the absolute value is always positive. Unfortunately, this is saying that our absolute value of y equals positive 1 is equal to negative 9. Can this be possible? The answer is no. Our absolute value is going to give us a positive answer, and because the whole absolute value, only the absolute value by itself, is equal to a negative answer, that's not possible. If we were to use the system we were using before and solve as if we didn't see that originally, we would get y is equal to negative 10, and then we would do the opposite case. So it used to be negative 9, so we're going to do positive 9, which means the left case, and we get positive 8. If I was to check my work and plug it back in, I would get the absolute value of negative 10 plus 1. Does that equal, to check, negative 9? Well, the absolute value of negative 10 plus 1 is negative 9. But when I pull out negative 9, because that's how we evaluate, I get positive 9. And as we can hopefully see, positive 9 will never equal negative 9. Same thing happens on the other side. If I plug in 8 into my original absolute value to check, I get positive 9 and my absolute value is equal to negative 9. And because when I pull something out of pull out an expression from the absolute value, I always becomes positive, I again get positive 9 is equal to negative 9. This does not work. Since this is not possible, things that are always false get us no solution. So that's important to recognize that this doesn't make sense the way it's written. The absolute value has to, when it's by itself, has to equal a positive number. So these 3 rules you need to write down. They're not really rules, but they're just a procedure for what we were just doing. So we want to isolate the absolute value expression, like if it was a variable. We want to separate into the original case, and we're really going to call the original case the case to the right. Right? We're adding whatever the distance is. And then the opposite case, that's the case to the left, where we're subtracting whatever that distance is. And then we're going to solve each case and get 2 answers for our absolute value. So in this problem, this is what we're going to do. It says solve the following equations and graph the answers. And so this we're adding in a little bit. We're going to graph the answers when we're finished. So I'm going to do exactly what I said. I'm going to take exactly what's written in the absolute value with the current distance. That's the to the right case, or the original. And then I'm also going to do the to the left case, which is going to be 2t minus 4, exactly what's written in the absolute value, minus 9. So now that I've split them into the case that goes to the right, the positive distance, and then the case that goes to the left, still a positive distance, but in the opposite direction, I solve each case, and then I'm going to get 2 separate answers, and I'm going to put those 2 answers on a graph. So when we do that, I'm going to do the one to the right first. Again, you can do it in any order, but I just like to do it the original and then the opposite. That's what I like to call them. So that's going to give me 13. I'm going to divide by 2 on both sides, and I get t is equal to 6.5. That's one answer. Okay? And now I'm going to do the same thing on the other side. Okay, I'm going to add 4 to both sides and then divide by 2t. Divide by 2. I apologize. Mistake. Oh, I found it. Okay, so I have minus 9 plus 4. That's going to give me minus 5. I'm going to divide by 2, and I get t is equal to minus 2.5. So I got my 2 answers. If I wanted to check, I could plug back in 2.5 and 6.5, and I should end up with something that works because I used the right-hand case, basically, where I'm going to the right. So I'm going 9 above what we're talking about, and I'm going 9 below. And I should get the right answer. And so when I do this, I'm going to have 1 point on the t-axis. We're going to call this the t-axis. 1 point on the t number line at negative 2.5, because that's where negatives are, if this is 0. And we're going to have 1 point on the t-axis. That's positive 6.5. This is clearly not drawn to scale. And so that is a graph of the answer, and these would be my 2 answers. It's either the one on the left, which would be negative 2.5, that's the left-hand case when we're going in the opposite direction, or the one on the right. Again, we do the same thing. We take the equation and then we do the two cases. So I'm going to do the one where we're going to the right. So we're going to add 10 one way. So we're going to have negative 1/2 s plus 2 equals 10. Then I'm going to do one on the left. Okay, and that means I have to do the opposite case. And this opposite case means I keep everything that was in the absolute value exactly the same because it has a variable. And then everything that's not in the absolute value, I must change its sign, going in the opposite direction. Now I'm going to solve each one. I have negative 1/2 s equals negative 12. Now I need to divide by negative 1/2, which really means I need to multiply by its reciprocal. So I'm going to multiply both sides by negative 2 over 1. And when I do that, two negatives cancel, and I get s, because they're multiplicative inverses. They give me 1. And then when I multiply this side, I get a positive 24, because a negative times a negative is a positive. That's one of my answers. My other answer, I'm going to solve the other side. Then I have negative 1/2 s equals 8. And then again, because I would have to divide by negative 1/2, I'm actually going to multiply by its reciprocal. So multiply by negative 2 on both sides. And then I get these two cancel, and I get positive 1s is equal to negative 16. Those are my two answers. I now must graph them. And so if I were to graph this, this is the s-axis. So I have a point at negative 16. This is 0, and I have a point at positive 24. And now I have graphed my answer and solved for my answer. Remembering for my absolute value, I should get 2 points, and those 2 points are a certain distance away from each other. In this case, we're actually going to start out with our points and work our way backwards. And so before I get to this, I want to kind of go back and see where we are. There is an equivalent expression for what we're using. There's an equivalent expression to negative 1/2, the absolute value of negative 1/2 s plus 2 equals 10. And we can find that equivalent expression by going back to the definition of the absolute value. The definition of the absolute value is going to be some distance, which means we're going to subtracting a central value. And that's going to be equal to how far away everything is from that central value. So it's going to be its distance. And so, well, let's look at what we're talking about. We are from negative 16 all the way to 24. That distance is 40. Okay? But 40 is how far it is from one end to the other end. In order to find out the part in the middle, what I'm going to do is divide that 40 by 2. And that's going to give me the distance away these end points are from their central value. So the distance away from the central value is 20. And so if I go 20 from negative 16, I end up at positive 4. And if I go 20 from positive 24, I end up at positive 4. So that means my central value is positive 4. But remember, I'm subtracting to find my distance. So I'm going to have x minus 4 for one part for my absolute value, and that's going to equal to 20. And if I actually checked this, I would see that I have x minus 4 equals 20, which would be the positive direction. And then I have x minus 4 equals negative 20, which would be the negative direction. And when I solve each one of those, I get my two endpoints that we started out before. And I get negative 16, And when I solve this one, I get x equals to positive 24. I get my two endpoints that I started with. So what I can do is, using this equation formula, I can figure out where my endpoints are. I can figure out how far away they are. I would divide that by 2 to give me the distance away from the middle. Okay? And then that should tell me where everything is. So when I look at this problem, it says write an equation involving absolute value for each graph. So when I start at -4 and go to 4, that's a distance of 8. Well, if that's a distance of 8, half of 8 is 4. So that means, based on my formula, which looks like this, okay, I'm going to have my distance of 4. Well, 4 away from -4 is 0, and 4 away from +4 in the other direction is 0. So I'm going to end up with x minus 0 in my absolute value. But when you subtract 0 from anything, from the x, you should end up with x. So my actual equation is just going to be the absolute value of x is equal to 4. Now I have another expression that I want to look at. And I'm starting at -6, and I'm going all the way to +2. That is a distance of 8. So that distance is also that distance is 8. So half of 8 is 4. So again, with my formula, I'm going to plug in 4 here. So I get the absolute value of some central value is equal to 4. And then when I look at this and I go, well, if I go 4 away towards the 2, 4 away from 6 gets me at -2. And if I go 4 away from +2, that gets me at -2. So my central value is -2. So I end up with x minus -2 absolute value, in the absolute value, is equal to 4. And since I can't leave this way, I want to make sure that I simplify as much as I can. I recognize that when I have two negatives next to each other, that's going to become positive, and I get x plus 2 is equal to 4. And this is my absolute value equation. Now that we're looking at a word problem, the same types of things apply. We have to look for clues as to what the distance away is, as to what is the central value is. And so if I have x minus c is equal to d, and d is going to be how far away from our central value. So we know that that's our formula, so let's see if we can figure out what it is. So the temperature of an enclosure for a pet snake should be at 80 degrees, give or take 5 degrees. Find the maximum and minimum temperatures and write an absolute value equation that represents the situation. So we're doing two things in this problem because of the and. We're finding the maximum and minimum temperatures. We're actually doing 3 things. And we're writing an absolute value equation that represents the situation. Well, just from looking at what we're talking about, we should be able to figure out what the maximum and minimum are. If what we're starting at is 80, that's the temperature for the enclosure, give or take 5. Well, if I give 5, or I take 5, if I give 5, then I'm really at 75. That's still okay. If I take 5, then I'm at 85. That's still okay. So my maximum and my minimum are 85 and 75. Well, if my max and min are 85 and 75, and they're each 5 degrees away, that means my central value is 80. And the distance away from 80 is 5. And so this is how I would write my absolute value equation to answer the second part of the question, write an absolute value equation that represents the situation. And this being the 75 and the 85, would be the maximum and minimum temperatures.